data will be stored. So the data address size will be maybe 32-bit size. The data size will be 32-bit size or 8-bit size. Okay. So every bit we are transmitting serially. Suppose YOT protocol or ITC protocol or APB protocol, if you consider 0, 1, 2, 3, 4, like every bit, 7, 8-bit means total 7 bits, total 8 bits, 0 to 7 will be transmitted sequentially one by one. Okay. But from the transmitter to receiver, how can we understand, okay, we have sent all number of bits. No need to send other bit. We need to stop after reaching to 7. We need to stop. Okay. So how we will know that? By using the counter. We will write the counter logic. Okay. From 0, we will initialize 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. Like that counter logic we will write. Okay. So that most of the projects in protocols and projects, counter is mostly used to count the number of clock cycles. Okay.
Yeah. But in I think in HBM series, there was a parallel data out.
Mm-hmm.
Yeah. Then at that time we don't need that counters. But in general scenario, if I want to replace the counters with any other thing, rather than changing the data, is it any have any circuits in in digital electronics?
In digital electronics, mostly counters. Counters means just for counting the number of clock cycles. That is the main
Yeah.
in encoder shifting, like consecutive encoders. Okay, in consecutive encoders also we will do the counting operation only. Like counting also we can count in terms of even number of values or odd number of values. Suppose you want to count 2, 4, 6, 8, 10, or some multiples of 5, 5, 10, 25, 30, like that. Any type of counter we can use. Okay.
Yeah. Yeah.
So still any doubts?
No. No.
Okay. So mainly counters and shift registers are used for data storing, because counters also made with number of flip-flops only, right? So whatever the counter you are taking, here is the, suppose there are 4 number of flip-flops. Okay, if you connect all the 4 number of flip-flops and sending the one output to another, if you connecting like this means that is a counter, asynchronous counter, synchronous counter. So what is the difference between asynchronous and synchronous? What is
Yeah.
the
It's
difference
depend.
between? Yeah.
Yeah. It's clock base. We can distinguish between synchronous and asynchronous. And actually, the point is, in HBM we can fetch a data accordingly. That particular.
HBM. You are asking
eh,
HBM,
Yeah. Yeah. High bandwidth memory.
high bandwidth memory. Okay.
Yeah.
In the memory, how we can use means in the memory also, first of all, how the memory will write write and read the data.
Through address lines.
Sorry,
Address lines. Through address
address
lines.
lines, through the address lines. Okay. So right, so how the counter will be used means, suppose if you are writing the data, so this is a transmitter and this is the receiver. Writing the data means what? From the transmitter, you are sending the data input to the receiver of particular memory location, right? So that is nothing but writing the data. Reading the data means what? Whatever the receiver data is there, the transmitter is receiving the data from from that particular memory location. That is write and read operation. Okay. So I will write transmitter, from transmitter side we will do the write operation. How this write will be performed? Uh, uh, okay, receiver is some memory. Okay, memory 2 I am considering. So memory 2 of particular location, like pointer, okay, mem of some pointer is nothing but particular location is equal to data input. Input data we are storing here. So at receiver side, what we will get? Receiver side is nothing but read operation. So data output is equal to, output only we will read, right? Output is equal to, from where we are reading? Memory 2 of particular location, wherever we are storing. Suppose in memory of first location or second location, wherever the location we are storing, from that we use the, we will read the data. The data will be sent to the output, data output, okay? So here what is happening? The pointer is there, right? So what is mean by pointer? Pointer is nothing but n number of locations, okay? Suppose this is the memory, okay? Try to understand, everyone. So this is the memory. In the memory, there will be n number of locations. So location 0, location 1, location 2, location 3, 4, 5, 6. N number of locations are there. So mem of write pointer is equal to data input. So suppose data input equal to 5. Okay, so where we are sending this data input? Mem2. Mem2 means name of the memory is mem2 is of pointer. What is the pointer here? Maybe 0, 1, 2, 3, 4, 5, 6. Pointer is the any one of the location. To that location, I am sending the data input. So suppose I want to store the data in third location. So mem of 3 equal to 5. So this is the writing the data. Writing the data means storing into the memory. Okay. Reading the data means what? Retrieving the data. That means getting the data from memory to the output side. Okay. So data out is equal to mem2 of pointer. Mem2 pointer is maybe third location or fourth, whatever the location. From that particular location, we are getting the data that will be sent to the data out. So this is the write and read operation of memory. Okay. Now, where the counter is used? The counter is used in the pointer. Okay. So pointer is increasing 1 by 1. 0 to 1, 1 to 2, 3 to 4, 4 to 5, like this. In memories also, we have different types of memories, like a RAM memory or ROM memory or FIFO memory or some LIFO memory or dual RAM, dual port memory. Okay, there are different type of memories. According to that, we use the counters to count the pointer. Okay, if count equal to 0, then pointer will be in 0th location. If count equal to count plus 1, 0th 1, the pointer will go to first location, then second location. So in FIFO, we do the read and write operation in the same way, first in, first out. Okay, high bandwidth memory, whatever the bandwidth, the hardware is same. Okay. Did you
Okay.
understand now?
Yep.
Hello?
Yes, I understand.
Okay. What about others? Any other doubts from Satyesh? Any other doubts from all? Okay. Let me ask a few questions in digital electronics. Okay. So, what is the difference between combinational logic circuit and sequential logic circuit? What is the difference between combinational and sequential logic circuit?
Combinational circuit doesn't use a flip-flop, whereas sequential uses flip-flop.
Why sequential is using flip-flop?
Because it is timing triggered, like clock triggered, sorry.
Because
Because of I use it as a memory, right?
okay. because sequential circuit uses the memory, whereas combinational logic circuit, it doesn't have the memory. So combinational means it doesn't store any data, so it doesn't have any memory state. Whereas sequential means it have the memory state, so that it will store the data. Okay, so that is the right answer, right? Any other answers from others?
When no feedback is present in combinational and feedback is present in sequential.
Okay, so combinational means whatever the input we are applying, we'll get output that. But a sequential means we will have the memory element. Okay, so this memory element will be connected in a feedback to the combinational logic circuit, so that output, the previous output will be stored in this memory and it will send to the next input. That's why we are telling this total circuit is a sequential logic circuit which store the data. Okay, so what about this memory element? What is that memory element? How we can design that memory element?
Using flip-flops or latches.
Okay, so
So
memory, tell.
yeah, using D flip-flop, there are different type of flip-flops available. So we can use according to the purpose we need.
Okay,
We can select. Yeah.
okay. So this memory is nothing but this memories came from the small memory element. Okay. So in combinational logic circuit, can you tell me which gate stored the data? That means which gate have input and output both are same?
NAND gate. Not NAND. Yeah.
It's a buffer. I like
Buffer.
buffer.
Sorry. So which gate have both the inputs say
Same.
A buffer.
Buffer. Okay. What about NOT gate?
It's inverted output.
So NOT gate is a inverter. Buffer will have
In-
both the input and output are same. Suppose if input is 0, output is 0. If input is 1, output is also 1. NOT gate means both are complementary, right? Like that you said NAND gate, right? So NAND gate,
Yeah.
NOR, XOR, XNOR, and these all are depending on the inputs. There will be two number of inputs and we cannot tell like the output will be same as a input. Okay, it is dependent. Okay, but buffer is a output and input both are same. Okay.
Okay.
So from the buffer, suppose if you buffer is a like this, right? Suppose if you connect two NOT gates in a cascade manner, then what is the output? If you connect two cascade NOT
same
gates,
input, same as
Yes.
input.
so here if we apply 0, output also 0. If we provide this output to the input, again it will be in a same loop, right?
Yeah.
So from this NOT gate, so here it is working as a buffer and it is storing the data. So it is working as a memory element, right? So from this memory element, a SR latch has generated. In place of NOT gate, just we are replacing with the universal gate. What are the universal gates?
NAND, NOR, NOT.
Then NOR.
NAND and NOR are the universal gate. Okay,
Universal
suppose
gates.
even if you take with the NAND or NOT circuit, so here I'm taking two NAND circuit. So two NAND circuits have two number of inputs. So here NAND also have two number of input. So what is happen here? The first NOT gate output is connected to the next NOT gate of the input, right? So next NOT gate of the input. So here the first NOT gate or second NOT gate. Here second NOT gate is connected to the first NOT gate input. So here second NOT gate is connected to the input of first and then first output is connected to the input of second. Okay. So from here we are taking these two inputs as a set reset. So if you observe, this is the latch for SR. If you write with a NOR operation, you will get NOR based latch, SR latch, right? So internal circuit you can go through, like if you apply 0 0, what is the output? 0 1 1 0 1 1. So you can practice that thing. Okay. So I already given the time, right? So you can practice that. So coming to my question. So what is the drawback of latch and why we are moving to the flip-flop? So here this SR latch or JK latch or D latch or T latch, everyone will work like a memory. So whatever the memory element we are using here, all those memory elements are nothing but latches, flip-flops. Okay. But here we have the latch, right? It is working very good with the memory element as a memory element. But why we are moving to the flip-flops?
Because it is level triggered, whereas flip-flop is stable and it is only changing at the edge triggering, like pause as or neighbors.
Okay. So what is the drawback of level trigger?
It can change the output like at any instance of time, which will be like not very good thing for digital circuits.
Okay. So in latches, we'll get some race around conditions, right? How we can avoid the race around conditions?
Master slave.
Master slave. So how master slave will work to avoid race condition?
Master always invert the slave's input.
Okay.
That's another slave into the not in race condition.
Okay. Okay. So to avoid the race conditions and also in latches, there will be the output will be dependent on every change of input. Okay. Whenever the input is changing, automatically it will reflect to the output. But whereas the flip-flop, what happened? Automatically it doesn't reflect to the output. It will wait until the input even the input change, it will wait until for the edge trigger. For every edge only the output will be changed, right? So that is the difference. Okay. So coming to the flip-flops, so what is the difference between SR flip-flop and JK flip-flop? What is the difference between SR flip-flop and JK flip-flop?
In JK flip-flop, when the input is 1 1, the output gets into toggle state.
Okay. So in SR latch, there will be a one condition, invalid condition, right? So how we are avoiding that invalid condition and memory state? What is the difference between D flip-flop and toggle flip-flop? Ujjwala and Yashwant, can you answer? What is the difference between D flip-flop and toggle flip-flop?
And D flip-flop is whatever data we are providing. If it is 0, then it will be reflecting on the output. Whereas and in toggle flip-flop, T flip-flop, if we are providing 0, it will be in the memory state. Whereas if we are giving it 1, then it will keep on toggling until the clock is applied.
Okay. So in the registers and counters, we use the D flip-flop and the T flip-flop, right? So why do we use the D and T for counter and register?
Because if we have to design a counter, we simply uh, provide the output of a T flip-flop to the next T flip-flop's clock, whereas in using D flip-flop, we have to make a circuit, and there will be like additional components to make a counter over there.
There's the add over in small reserve.
Okay.
But
Okay. Sekar, who
from
is
either to
Sekar? Hello. Who is Sekar? How did you join to this group?
hello, ma'am.
Yeah.
Ma'am, brother, this is my first section, ma'am.
Sorry.
This is my first section, ma'am.
This is your first session. Okay. How
Yes,
you
ma'am.
have joined? Through whom?
Through WhatsApp link, ma'am.
Through?
WhatsApp link, ma'am.
In which group you are there? Can you tell your number?
Or
Can you tell your contact number?
my 96
96.
180
Okay.
44
Okay.
579.
But you are not there. Do you know Akhil?
Yes, ma'am.
You have joined through Akila.
Yes, ma'am.
Okay. Last session also you have joined, right? I think.
Yes, ma'am. But someone telling some work to
Okay. Okay. No problem. Okay. Yeah. Okay.
I'm from background, then. Yes.
Okay. Do you have knowledge in digital electronics?
Yes, ma'am.
What are you studying currently?
Present I am in job, ma'am.
Okay. 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 I will talk to you later. Okay. Yeah.
Yes, ma'am.
Tell. Why do we use the D flip-flop and T flip-flop for the register and the counter? Ujjwala, can you answer? Pankaj. Hello. Ujjwala and Pankaj.
Yes, ma'am.
Yeah. Why do we use T flip-flop and D flip-flop in registers and counters? Why particularly D used for register, particularly T for counter? Don't you have
The
idea?
main reason,
Yeah, tell.
ma'am, the main reason is using D is it provides same input at the output, and the input and output will be same.
Okay. So in the D, mainly the input and output or both are same. Nothing but it is working like a memory state. And register is also nothing but a memory, right? So that's why we use the D flip-flop. Okay. So what is
Yes,
the
ma'am.
difference between flip-flop and the register? What is the difference between flip-flop and register? I'm asking very basic questions. The interview questions and all already you did the assignment, right? There you will find all the interview questions. Here I'm just asking basic questions. What is the difference between flip-flop and the register?
Ma'am, flip-flop is a memory element. It
Okay.
store a single bit of data, but a register is a collection of flip-flop. Example for register is a flip-flop, ma'am.
Okay. So flip-flop, so registers will store multiple data, n-bit data. So the collection of flip-flops, so n-bit, n in the sense 3-bit means 3 flip-flops can be used. 16-bit means 16 flip-flops can be used, right?
Hmm.
Yeah, tell. Hello. So in digital electronics, we have different type of registers like shift registers. In shift registers, there are serial input, parallel output, parallel in serial out, some bidirectional shift register, universal shift register. If you go for microprocessor, there will be different special purpose registers, general purpose registers. Okay. In the general purpose registers, mainly we'll store the data like R1, R2, R3. Okay, we will store normal data. But if you go for special purpose registers like a program counter or accumulator or instruction register, so there are used for some special purpose. Program counter is used to fetch the data. Okay, like instruction register is used to send the instructions to the decode stage. So there are special reason for those registers. Okay, but commonly registered in the sense the combination of flip-flops we can store n bit data. Okay. So what about counter? So counter we have discussed it now before clearly, right? Okay, coming to the final state mission, what is the difference between Mealy mission and Moore mission, and which one is used practically?
Mealy depends on both the current state and the input state, whereas Moore will rely on only the current state.
Okay, so which one practically used?
Mealy actually for the input purpose.
Okay, why we won't use the Moore? Why we won't prefer Moore practically? Hello.
Yeah,
What are the
I'm listening.
limitations? What are the limitations with a Mealy, and what are the limitations with a Moore?
Yeah, I need to find that.
Okay. So have you tried the example?
In assignments or in fact means
Normal.
any.
Have you tried with any examples with for practicing?
Yeah, the I did an assignment actually
Okay.
where we count the number of input means what the where is the what's the parity actually.
Okay. So in Mealy, we have some glitches. At the output side, it will generate some glitches, right? So do you have any idea about that? Why it will provide the glitches and how we can avoid the glitches, and why Moore is preferred practically compared to the Mealy? Do you have any idea in that?
Not yet.
Okay. Okay, then you need to practice more on finite state mission. Okay. What about others? Can you all please join for the next session again using the same link, because session limit is 40 minutes. So using the same link, please join again. Yeah. So can you tell me what are the glitches occur in the Mealy, and how we can avoid the glitches in the Mealy, and which is practically preferred in terms of area, in terms of storing the data, and in terms of glitches and hazards, which one is preferred practically? Okay, so I think you need to practice on finite state missions. So have you gone through the memory state? Memory. Have you gone through the different types of memories? Hello.
Is it for me?
for all. Okay, so I think you need to practice memory and the final state mission, no problem. So you can practice parallelly, okay? So coming to the Verilog HDL, how many of you have some basic idea on Verilog? How many of you have some basic idea on Verilog?
Yeah, I
Very-
have basic idea.
Okay,
I have
okay. Okay, so in hardware description language, okay, so we have two types of hardware languages, right? One is a VHDL, another one is Verilog.
He's in the sniper position.
Bro.
Yeah.
So which one can be preferred mostly? Whether VHDL or Verilog HDL? And what are the drawbacks with VHDL?
Can you repeat your question?
So in hardware description language, we have two types, two languages, right? VHDL and Verilog HDL. So which
Yes.
one can be preferred practically in most of the industries in any country? Which one is preferred?
Current like Verilog is used widely. VHDL like Verilog is like is advancement from the VHDL.
Okay,
Yeah, like widely it is used. Verilog is widely used right now, and then currently system Verilog also is like getting widely used. Started used by many people.
okay.
This-
So before that, when will you be free for mock test, everyone, for mock interview, everyone? So yesterday Mayank said a Wednesday, but he didn't answer when I asked in the group.
Ma'am, I texted you that I will be taking it on Saturday or Sunday.
Okay. What about others?
Ma'am, this Sunday I am ready to do more test.
This Sunday. Okay,
Yes, ma'am.
okay. What about Ashwant and Ujjwala?
Ma'am,
Yeah,
ma'am, next Friday or Saturday, ma'am.
okay. What about Satyesh? Saturday. Okay. Okay, today we'll start the Verilog HDL anyway. We'll just discuss the introduction topics today. And from next session, we will discuss into the coding part. Okay. So coming to the Verilog HDL, you already know everyone. So in VLSA, whatever the digital circuits are there, we are going to implement all the digital circuits in terms of language. Okay. So why the language is mostly important? In olden days, we don't have any languages. Directly, we have designed the digital circuits. Okay. So like by using the transistors, normally, manually, we have connected. But afterwards, when the number of transistors are increasing day by day in integrated circuit, like thousands of transistors, lakhs, crores, millions of transistors are getting. So at that time, we are not able to design a circuit manually in a silicon wafer, right? So debugging is also very difficult. So for that purpose, a language is introduced for the hardware, both the analog and the digital. We have analog hardware description language called Verilog HDL and a digital Verilog HDL. Both the analog that syntax is different. For digital, these syntax are different because digital we have the gates, flip-flops, registers and all, right? In analog we have some registers, capacitors, some those analog components are different. So both have different languages. Okay, so like we have the high level languages like a C, C++, assembly language for processor design, and different type of languages or higher like machine language. There are different languages, right? But why specifically hardware description language is introduced? Hello. Why specifically hardware description language has introduced?
Maybe reduce parasitics.
Okay.
As far as I know, we should have mentioned the wire diagram also.
Okay. Any other answers?
Because of the complexity of the circuits.
Okay. See, if you say high level language, it doesn't actually used to describe the hardware, right? Mostly for software purpose. The C language, if you take example, we can design most of the games, gaming purpose, or most of the software purpose we use for logical creating. But we cannot generate any hardware like any gate or to store the register. We cannot design the register or wire connections between one circuit to another circuit. We cannot generate that thing. And different type of like a clock is main important, right? So we cannot generate the clock signals. There are so many things. Okay, so for that purpose specifically HDL, hardware description language, has introduced to design the hardware circuits, okay, like a digital circuits. Okay, so that is the main reason. So that's why in HDL also we have two types of hardware description language. I think everyone know that VLSI design path. What are the various steps are involved? Okay, if you don't know, I will share the recorded session of two demo sessions. Go through the recorded sessions. You will get the idea on what is meant by VLSI and flow of the VLSI and what are the future technologies and all. Okay. So coming to the different types of HDL, we have VHDL and the Verilog HDL. Okay, what are the comparison between these two and why Verilog HDL is used worldwide? Means VHDL is somewhat complexity. Okay, complex. That mean we need to include the standard libraries. So whatever the operation you are doing, if you are performing any mathematical operation or regarding the circuits and all, we need to include special some what we tell standard libraries. Okay, so some standard libraries we need to use, and code complexity also more. So in Verilog you can write any code like a simple codes within 2 to 3 lines also, the main logic. But in VHDL it is not like that. The syntax is very complex. Okay, so Verilog is used to used easily, and we can learn easily and we can implement easily. Okay, that's why Verilog is so popular than VHDL. Okay, everyone understood up to there?
Yes, ma'am,
Yes,
understood.
ma'am.
Okay.
Yes, ma'am.
Okay. So why do we use the Verilog HDL? So Verilog is the hardware description language. All the things just now I have discussed, right? Go through the theory part. I will share this material to everyone today, so you can go through the material. Okay. So it is different from the general purpose programming language, and it specifies the registers, wires, gates, clock and all. Mainly use it for the hardware purpose. We can do both synthesis and the simulation. Okay. So can you tell me what is the difference between synthesis and the simulation? What is the difference between synthesis and simulation?
Synthesis would be actual implementation of the hardware, whereas simulation will be how the signals will be working only on the computer.
Okay. Other answers? What is the difference between synthesis and the simulation?
Simulation, like whenever we write a code, like we need to test it before the code whether it is correct or not. It is to debug. So if you simulate and we can debug the code, like whether the expected results as the code according to the design. So synthesize is after simulating the code, like if you want to and then integrating multiple uh, blocks of the design, and then we can simulate, like we can synthesis.
Okay. Okay. Any other answers? Okay. Synthesis is nothing but generating the circuit netlist. Okay. So by using the Verilog HDL, we will write some program, right? So if the program is generated, if the program is generating the RTL design, then it is called synthesis. Okay. So nothing but from the program, we are generating the circuit netlist or RTL circuit. Okay. Simulation is nothing but once the circuit is generated, suppose a circuit called full adder. Full adder have some three gates are connected to one XOR gate, and it have some AND gates will be connected some OR gate, right? So this is some circuit netlist if you take any architectural level also. So writing a Verilog program and generating this circuit is nothing but synthesis. So after doing the synthesis directly, we cannot send this circuit to the backend process, to the physical design process without doing any verification, right? So we don't know whether our output is getting correctly or not. Blindly, we cannot send that circuit to the physical design. Maybe there will be some connection mismatch or some functionality mismatch, or sometimes we may not design perfectly in terms of number of blocks. Maybe we have missed some hardware block. So these are the different criteria. So without doing the verification, we cannot send the design to the backend, the physical design process, right? So for that purpose, we are doing the simulation. Okay.
So simulation is like simulating a synthesized design, like synthesized circuit. Hello.
Hello.
Yeah. Simulate like simulation is like we go like we need to simulate the synthesized circuit. So
Yes.
the design will be the synthesized circuit.
Yes, yes. Design means generating the RTL circuit netlist. Verification means after designing, we do the verification by applying the input stimulus. We will check the output. If output is correct, our design is correct. If output is not correct, our design is not correct. Okay. So simulation is nothing but applying the test input, test stimulus, and checking the output. That is nothing but stimulus. Okay. Did you understood everyone?
Yes.
Yes, ma'am.
Okay. Any other doubts, others?
No, ma'am.
Okay.
Ma'am, we can say the simulation is simply the compiling the program.
See, compilation is different. Okay, so compilation means it just check the syntax error. After compilation, we need to do the simulation. Simulation means getting the output. Before the simulation, we do the compilation. Compilation means it will check in our code if there are any syntax error, or if we miss syntax error means if you miss any semicolon, if you don't put any semicolon, or if you didn't write anything. Just a second. See, syntax errors are nothing but like syntax wise, if you miss any semicolon or if you didn't write the keyword properly. Okay, so these are check under compilation. Once compilation is free, then the simulation will do the exact code. So that will generate the output. Okay, did you understood the difference between compilation and simulation?
Yes, ma'am.
Okay. First, any program, whether you are writing the design or you are writing the test bench, first it will check all the syntax errors. It doesn't check the functionality in compilation. Okay. It doesn't know about the functionality. It knows about only the syntax error. Once syntax errors are free, that means compilation is free. Once compilation is successful, then it will go for functionality wise. It will check functionality wise. Okay. If functionality wise, if anything wrong in terms of connections, or if any block is mismatch, like that will generate, it will generate the wrong output. Okay. Next, different levels of abstraction in Verilog HDL. So in Verilog HDL, we will write different level of programming. Okay. So suppose in digital electronics, a problem statement has given. Okay. So if any problem statement has given, if you want to draw the output circuit diagram, so what are the steps you will follow to draw the circuit diagram? What are the steps you will follow to draw the circuit diagram? Suppose a problem statement is given, whatever, suppose I am telling you to design a 16 by 1 multiplexer using 4 by 1 multiplexer. Okay. So for that, if you want to generate the circuit diagram, what are the steps you will follow? What are the steps you will follow?
Of the inputs, what is given
Yeah.
from the inputs, like if it is 16-bit inputs, like we need to see how many inputs given and then expected outputs.
Okay. Next. What is the next step?
We calculate how many muxes are required.
Okay. Still?
So if it is needed to design by 4:1 mux, so there will be 4 data lines and then 2 select lines. So we have 16 bit of so there we have the input 16 bits. So we need to do we need to arrange it we need to connect it in order to get the expected output.
Okay. Next. What is the next step? Can you answer, Satyesh, Ashwant, or Ujjwala? Remaining others.
So the question is, what is the question exactly?
So a problem statement has given, suppose a simple
Okay.
example, you need to design a 16:1 multiplexer using 4:1 multiplexer. Or
Okay.
suppose any problem statement like a 4-bit input is there. In the 4-bit input, the even number of ones in each input, if there are even number of ones in each input, output must be 1, otherwise
Okay.
0. Okay, like this. So how you will draw the circuit diagram for this? What are the steps you will follow? Or you
So it is
to
4
draw
is to 1.
direct-
Yeah, it is 4 is to 1 mux. So we need to take 4 is 1 multiplexer. So it covers 16 input. So it takes 16 input line. Then each 4-bit multiplexer can be connected to another one single multiplexer, like 4 is to 1 multiplexer, so that we get a single output,
Okay, okay.
the
Can you
final
tell-
output.
Okay, that you are telling simply, as you know. But for second problem statement, can you tell how you will draw?
What is the second statement?
There is a 4-bit input.
Okay.
4-bit input means 16 number of input combinations will be there. In 16
4.
number, mm,
Okay. Yeah, 16 number of combination. Yes.
in each combination, if there are even number of ones, the output must be 0.
In each bit.
In each combination,
Okay. If each combination is even, which means
we will
so
design a
2
truth
input. So we need to draw the truth table, and then we need to simplify the equation, and we need then yeah. Can you
how will get the circuit diagram? So here are the two number of even number of ones. So here you will get
Yeah.
1. Here odd number of ones. Here also no ones. Here also odd number of ones. Odd number of ones. Even number of ones. So like that for 16 combinations we will write the output. So here what is the next step to get the circuit diagram?
Next step.
You will write the output expression, right? Whether POS
Yes.
OP format.
Yeah.
From the output
By using
expression,
K-map, we will write the expression, ma'am.
okay, by using K-map or Boolean algebra.
K-map, we will get this. Yes, ma'am.
Okay. And then next,
Through that expression, we will make the circuit.
okay, from the expression we will make the circuit diagram. So
Circuit
this is
diagram.
what, yeah. So these are the rules you need to follow to design any digital circuit, whether it is a combinational or sequential, whatever. You need to understand the problem statement first. You need to understand what are the inputs, what are the outputs, and how many combinations it will generate. And if there are any control signals in the sense clock or reset or enable signals, these all are control signals. Okay, you need to check accordingly. You need to draw the block diagram and then truth table. From the truth table, output expression. From the output expression, gate level circuit. From the gate level circuit, if you want to convert into transistor level, you can convert the gates into the number of transistor, I mean CMOS circuit. So this is the flow we need to follow, right? In the same way, in Verilog HDL, we will have 4 levels of abstraction, right? So here, if you observe, one is a behavioral model. We can write the program in behavioral model, data flow, gate level, switch level. So what does it mean? Behavioral means first we will draw the truth table, right? In digital electronics. So by using the truth table, if you write the program, that is the behavioral modeling. Okay. If you write the program by using the output expression from the truth table, whatever the output expression is getting, if you write the program using that output expression, that is a data flow model. Okay. From the output expression, you will generate the circuit, right? If you write the program for this circuit netlist, then gate level modeling. Okay. So from the circuit, you will be converting the CMOS, right? If you write the program using the CMOS circuit netlist, then it is a switch level modeling. Okay. In Verilog HDL, these are different levels of programming we can do. Have you understood now?
Yes, ma'am.
Okay. Up to here, clear everyone? Hello. Up to here, is it clear? Is there any
Yes,
doubt?
ma'am.
Okay, so please practice up to here and complete the digital electronics. In the next session, we will discuss the coding part. Okay, we will start the coding for each example. Okay. Hello.
Okay, ma'am.
Yeah. Okay, then all. Thank you.
Thank you.
Yeah.
Thank you, ma'am.
Okay. Bye.